All right, advanced math A, here we go. We got lesson 8.1.3, more applications of exponential functions. All right, so let's say that you've got $1,000 and you want to invest in it, and you've got two investment options. Both of them are going to give you an 8% annual interest rate. So that means they're both going to pay you 8%. So you got two options. Number one, option one, you're going to invest in bonds and they'll pay you 8% simple interest. Or you can put your money in a credit union account, which pays you 8% compounded interest, and that's going to be compounded annually. All right, so will the option you choose make a difference if they're both offering you 8%? Hopefully you already know the answer to this because we kind of touched on it in a previous unit. So let's look at a bond with simple interest. So a bond is basically where you loan somebody money and they tell you, okay, I'm going to pay you for the loan of the money that you gave me. So every year I'm going to pay you a percent of what you let me borrow. And then eventually they give you the money that they borrowed from you. You'll get your $1,000 back eventually, but every year that they don't give it back to you, you get a certain percentage. There you go. All right, so here we go. Investing in bonds. This is how it would grow if you invested in bonds. So here you see that you started with $1,000. After a year, you got 1,080, which makes sense because 8% of 1,000 is 80. So that you still are owed $1,000, and then you made 80% in interest. After 2 years, they still owe you $1,000, but now they owe you $160 because you've got 2 years of 8% interest. And then here you've got 1,240 because we've got $1,000 that they still have to pay you back. And then you've got 3 years of $80 of interest. So that means on the fourth year, I should just increase this by $80 more. So if I increase that by $80 more, I would have $1,320 at the end of 4 years. So how does the amount of money grow with simple interest? Well, the way that it grows is you take your initial investment, so your investment times your percentage, which is 0.8, and that is what it increases by each year. All right, so that's how it's growing. We take our investment times, oh, that's supposed to be 0. Sorry, not 80%, 8% interest. So 0.08 multiplied by the investment, that's how we're increasing by that every year. And we're increasing by the same amount every year. So this says, what percent would your balance have increased by at the end of the fourth year? Well, we started with 1,000. And by the end of the fourth year, what's our increase? It's a $320 increase. So what's 320 out of 1,000? Let's see. 320 divided by 1,000, 32%. Which makes sense because I added 8% each year. So 8% in the first year, 8 more in the second, 8 more in the third, 8 more in the fourth. That's a total increase of 32% off of my initial investment of $1,000. So that's our bond with simple interest. Okay, and then there's a credit union who says, okay, if you give us $1,000, we will pay you 8% compounded interest. Okay, so compounding is slightly different. Now we see that after the first year here, we have the same exact amount. It's an 8% interest, so we've got 1,080. But the next one doesn't say 1,160, it says $1,166. Now the reason for that is not only are they going to pay you 8% on this original $1,000, but they're also going to pay you 8% on this $80 right here. So they're doing 8%. So if I take 1,080 and multiply it by 0.08, that's where 1.08, sorry, 1080 times 1.08, I've got 1166.4. And then we're going to multiply that by 1.08. And that's where I'm getting the 1259.71. And I'm going to multiply that by 1.08. And I'm up to 1360.49. All right, so if we look at just the tables here, we can tell that from here to here, we're adding 80. From here to here, we're adding 80 more. From here to here, we're adding 80 more. So it's a constant increase of $80 each year. Whereas on this one, we're not just adding 80, we're multiplying by 1.08. And here to here, we're multiplying by 1.08. And here to here, it's 1.08. And here to here, it's 1.08. And it's multiplication that's happening. Which means since this is multiplication, this is exponential. Since this is addition, it's linear. So this is an arithmetic sequence, maybe, that we would look at, whereas this one is a geometric sequence. Okay, so instead you invest $1,000, blah, blah, blah. How's it growing? Okay, it's growing by being multiplied by 1.08 each time. So it's multiplied by 1.08 each year. So how is the interest compounded? So the interest is totaled based on your total amount of money and not your initial value. This one, the 8% is always based off of the initial value. Over here, the interest is based off the previous value. So I took 1080 and multiplied by 1.08. So I'm getting interest on top of interest. So that's what the difference really is. Whereas this, the interest is always calculated from the initial value. This one, the interest is calculated from the previous one. That's why year one's the same. Year one's the same because they're both calculating interest off of $1,000. But in year two, they're different because this one calculates the interest for year two based off of 1,080, where this one still calculates the interest off of the initial value. So compounding interest is calculated from the previous term, from the previous term instead of the initial term or the initial value. All right, what will the balance of the credit union be at the end of the fourth year? Here we've got 1,360.49. By what percent will this account balance have increased at 4 years? So let's see, 360.49 is the increase, and we're going to divide that by 1,000. So if I do 360.49 divided by 1,000, that increase is 36 and then a little bit more over here. See, so it's going to be 36. We'll just call it 36%. So at the end of 4 years, when we were doing the simple interest, we increased by 32% because it's 8% each year. But this one started by doing 8%, and then it was a little more each time, so that the total increase was a 36% increase instead of a 32% increase. Which grows more quickly? Obviously, compounding. All right, so we're going to graph the two situations through 8 years. Wow, that's a lot. All right, so we're going to graph the two situations through 8 years. So let's do, for our x values, we're going to do 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to do the simple interest. And then we'll do the compound. All right, I'm going to pause so that you don't have to watch me use my calculator for a few minutes. So I'll be back in a second with all the calculations here. All right, so we've got all of our data for simple interest. And again, it's just adding 80 each time. So after 8 years, simple interest will have $1,640 because we're just going to add $80 each year. Compounded in green over here starts at 1,000, goes to 1,080, just like simple interest, but after that it starts taking off because we start calculating interest based off the previous number instead of based off of 1,000. Well, this one always calculates simple interest based on 1,000. This one calculates interest off of the previous number. And so this one makes it up to 1,851 after 8 years, which is like $211 more that would be made in compounding annually over just simple interest. Okay, so I'm going to go ahead and make my graph to look like this. I'm going to put 1,000 down here. I'm breaking my graph, which is fine, just so we can see the important parts. So I'm going to make it in 50s. So go ahead and set up your graph like that. I'll graph the simple interest one real fast. I'm going to pause here and graph it, and then we can take a look at it. Okay, so there I've graphed the simple interest. We can see that this is a line because we're just increasing by 80 each time. I've made it discrete because it looks like they're just going to pay us at one time at the end of each year. So I've just kept it discrete so we get our $80 payment at the end of each year there. All right, next we're going to take our green pen and we're going to do the compound interest. Now compound, the first 2 points are the same as simple interest, and then that's where it's going to start changing. So I'm going to pause real quick while I graph the green ones. All right, so there we've got our green one, and we can see it's not a steep curve, but it's definitely pulling away. Look at the different red. Look how far away. So right here, it's right next to the red one. Here it's a little bit farther away, then a little bit farther away, a little bit farther away. So it just keeps on pulling ahead over time. So the farther down we get, the farther away the green and the red functions are going to end up being. And this is going to be a curve over here. So it's not a super steep curve, but you can definitely see that towards the end, we're making a lot more money in the compounded interest situation because it's exponential versus the red one, which is just linear. All right. So let's model the two types of investments with equations. So for our simple interest, we'll do in red. Since this is linear, the increase is $80 every year. So I'm going to say 80 times the number of years. I'm going to make Y is going to be the account total. And I'm going to let X equal the number of years, or time in years. So $80 every year, and then plus the $1,000 initial value. So this is my y-intercept. and then the slope is increasing by 80 each year. The compounded one, if we were to do compounded, that would be y is equal to, the initial value is 1,000, and then we're multiplying by 1.08 to the x power. Now the 1.08 is two things. It's 1, so that means 100%, which means I'm going to get my $1,000 back. And then plus 8% more. So that's 1.08 to the x power. Remember what we did on the last section, on the last two sections, if our b value, which is this right here, is greater than 1, then it's an increasing function. So if you just put 0.8 in here, that's less than 1, that's a decreasing function, and our money isn't decreasing, it's increasing. All right, consider the two types of investment sequences. As sequences. Write an explicit equation for both. Okay, so this is the simple interest one, and this is the compounded interest one. So if we were writing this as a sequence, we would do something like T of n. And then we need the 0th term. So I would subtract 80, and that'd be 920. And then plus 80n. And we've seen on our homework problems that there's other ways to write this as well. We could do A of n is equal to the initial value of 1,000 plus 80 times n minus 1. So this just says one less time for n, and that's why we have the, this uses the 0th term, and this uses our A1, our first term here. For the other one, we do T of n. So I'd have to take 1,000 and divide by 1.08. So 1,000 divide by 1.08. And the 0th term would be 925.93. 925.93. So this would be 925.93 and then 1.08 to the nth power. Or we could do A of n is equal to 1,000, the initial value. Then we would do 1.08 to the n minus 1 power. All right, which type of account are the following sequences? Well, let's see what's happening here. Are we adding the same amount each time? Definitely not, because of that 0.62. So let's take 8427, 8427 and divide by 7950. Comes out to 1.06. Let's see if this is the same thing for this one. 8932.62 divided by 8427. 1.06 again. So this one is multiplying by 1.06. So that would be 6% interest compounded annually. All right, what's the explicit equation for this one? So this one, if we were to do it the old way where we use the 0th term, I still need my 0th term. So I'd take 7950, 7950 and divide by 1.06. So the 0th term would be 7,500. So 7,500 is the 0th term. So this would be 7500 and then 1.06 to the nth power. Or we could do A of n equals the starting term of 7950, and then 1.06 to the n minus 1 power. So this one uses 0th term, this one uses the first term in the sequence. This next one looks like they're adding 12 each time. So it's plus, so that would be a situation where it would be arithmetic for the sequence. So if we subtract 12 going the other way, we get 288. So the 0th term would be 288. So on this one, we would get T of n equals 288 plus, and then it'd be 12n for each term. Or if we wanted to use the new method for doing this, the initial value is 300. And then we're adding 12 each time for every n minus 1 terms. So again, this one uses the 0th term. This one uses the initial value. Next part, another investing option is a money market account that offers 8% interest compounded quarterly. Quarterly, something new. So when we do it quarterly, we do 4 times a year. So if I take 8% interest and I'm breaking it up quarterly, what I'm basically doing is I'm taking that 8% and I'm dividing it up 4 times during the year. So every 4 months, no, every 3 months, I'm going to get 2% interest. So I'm going to get it 2% after 3 months, 2% after another 3 months, 2% after another 3 months, and then after a year, that'd be a total of 8% that I would get. But it's compounded each time. So if we were to write an equation for this one, we would do y equals, the starting value is 1,000. We're going to do the 100% because we're going to get all of our money back. And then we're going to take the 8% interest and split it up 4 times during the year. So that's where I'm going to get this 2% from. And then we're going to take our number of years and multiply it by 4. Because now each year has 4 time periods in it to compound. So I'm going to divide my interest by 4 and multiply my years by 4. Because this is how many terms are going to be in a year. So after 1 year, I should have 4 different compounding terms. So the equation actually for this is 1,000 times 1.02 to the 4x power, where x is the number of years. Okay, so if I were to use this to calculate the investment after 4 years, I would do 1,000 times 1.02, and then it's 4 years, so that's 16 terms because each year has 4 terms in it. So taking out my calculator, if I do 1.02 to the 16th power, I get that huge number, and then I'm going to multiply by 1,000. So it would come out to approximately $1,372.79. Now compare that to compounding annually. See, if we compound quarterly, we actually get more money than the compounding quarterly or compounding yearly. So this is yearly, I get $1,360.49. But if I compound every quarter, I get $1,372.79. So I get a little bit more, even though it's still 8%. If the more times you compound, the more money you'll make. So each compounding is going to make you a little bit more. All right, last one. You have 3 options available for you to invest $500. You want to find out which one is going to give you the most money after 10 years. So there's a bank, and there's this banker, and he says his bank is going to offer you a growth rate that looks like this. Here's your $500. After a year, it's $600. After 2 years, it is $700. After 3 years, it's $800. 4 years, it's $900. Okay, so it looks like they're adding $100 every year. Okay, so the equation for this one would be y equals your $500 would be your initial value. And then it looks like for every year, they're going to give you $100 more. Okay, so every year, looks like we're gaining $100. Is that right? Yeah. So let's find out how much we would have after 10 years. So we do y equals 500 plus 100 times 10. So this is 1,000. Looks like we're going to have $1,500 after 10 years. All right, next one. You got a friend and he's like, oh, you got to try this that I've got. I get compounding monthly, and this is what my bank is giving. This is the equation that my bank's giving you. Okay, so then we would say, okay, if it's compounded monthly, then if we do 10 years, then our equation would be y equals, instead of 388, our initial value would be 500. And it's 1.008. And then this is the number of months. So we're going to do 12 times 10, because now we've got 10 years to work with. So that's 120 time periods there. All right, so we're going to do 1.008 to the 120th power, and then we're going to multiply by $500. And we would have, after 10 years, $1,300.87. Okay, last one. Looks like they're doing it quarterly. Okay, so how much are they multiplying by each quarter? So I'm going to do 515 divided by 500, 1.03. And let's just double check to make sure that's still happening. So if I do 515 times 1.03, we get 530.5. Okay, so yeah, it's working. All right, and this is quarterly. So for this one, we'd have $500 in there. The multiplier is 1.03. It's quarterly, so I'm going to do 4 times 10 years. So I end up with $500, 1.03 times 40, because there's 40 time periods in 10 years since we're doing it quarterly. All right, so 1.03 to the 40th power, and then multiply that by 500. And in this situation, I would get $1,631.02. Looks like that last one's the best one. Looks like the monthly compounding after 10 years wasn't quite as good as what the bank was offering, giving you $100 every year. But when we're compounding it quarterly after 10 years, this last one is going to give us the most amount of money. All right, that's all I got for you. Math hard. See you later.